Assalamualaikum warahmatullahi wabarakatuh. Well, as noted earlier, if the sample correlation R is close to 1 or -1, we know that it definitely indicates a significant linear relationship. But what if we get values around 0.31 or 0.59 or 0.81? So what can we say about this relationship? Is it linear or is it weak linear? Is it significant linear relationship? So how confident are you to say the relationship is linear? Well, in order to state confidently, well, you have to decide by doing a hypothesis testing. Now, the standard writing of the null hypothesis statement are given as follows. Well, most of the times, this is what you will be writing down as the null hypothesis when you say that population correlation is equal to 0. So when you say population correlation is equal to 0, in other words, it means no linear relationship. Okay, no linear relationship since the value of correlation is 0. Sometimes, depending on the question, it can also be written as such. So here we are saying that the null hypothesis states that the population correlation has a positive linear because it is greater than or equal to 0, positive linear relationship. And here we are saying that the null hypothesis is about stating that the population correlation here has the negative linear relationship. So here is an example of one-sided test where the critical region is just going to be on one side of the distribution. Yeah. All right. So now the test statistic to be used in the hypothesis testing is given as such. And of course, the procedure related to hypothesis testing is similar to what you have already seen in chapter 3, 4, and 5. So we just follow the same idea, except that on the second step, this is the test statistic that you have to use. And of course, you can see that based on the test statistic here, you will have to refer to the t distribution in order to find either the critical value or p-value, and the degrees of freedom is going to be n-2. Okay, so without further ado, let's look at the example given here. Based on the sample correlation coefficient that you get in example 6.2, so the sample correlation coefficient that we get is r equals to 0.8967. So this is what you get in example 6.2. Test the significance of the correlation coefficient and alpha 0.05. So this is the area, the critical region. And can the null hypothesis of having no linear relationship, so this is H null, be rejected? Consider both the traditional method and the p-value method. Okay, so we are going to start off with the first step, which is writing down the hypothesis statements. And based on these statements given here, we know that H null is going to be rho equals to 0 because this is correspond to having no linear relationship. And H1 is rho not equal to 0 because it has to be complementary. Yeah. So this is an example of a two-sided test. Now on the second step, step 2, you need to compute the test statistic, which is given by this formula here. Okay, and we're just going to plug in the value of R, which is 0.8967, and n here is 6, so 6 minus 2 is 4, 1 minus 0.8967 squared, and you will see that the result that you get is going to be 4.0517, about this value. Now the third step is to come up with the critical region or critical values. So here is the t distribution curve. This is a symmetric curve. So this is t distribution, this is at 0.0, and since this is a two-sided test, therefore the critical region is going to be 0.05 divided by 2, and we're going to have it at both ends. So here is 0.025 and similarly at this one here is also 0.025. yeah. Okay, so next degrees of freedom related to this example is n minus 2, which is equal to 4. 6 minus 2 is 4. 6 is the number of samples in the example given here. Now our job is to find what's the critical value, which is the point here on the horizontal axis, these 2 points here, and we know that we're going to have positive and negative value. So if you refer to the t-distribution table with alpha 0.025, okay, the area to the right side here is 0.025. Remember, this is what we are looking for. This is 0.025, and the other one here is also 0.025. So since the right area is 0.025, this is what you need to refer to, alpha 0.025. Degrees of freedom is 4, and so the critical value at this point is 2.776, right? So here is 2.776. Therefore, this one here is going to be negative 2.776 because they have the same value, just different signs, positive and negative. Yeah. All right. So let me just spell it properly. Therefore, the confidence interval is plus minus 2.776. Now let's look at the fourth step. Well, the fourth step is to decide. So this is the test statistic. 4.05 is going to be somewhere here. Okay, somewhere here. So it is inside the critical region. So what we can say is that we are going to reject H null since the test statistic falls into the critical region. You can be specific. What's the value of test statistic? The value of test statistic is 4.0517, and therefore we're going to make a conclusion. We're going to say that enough evidence to say that the population correlation is not zero. The population correlation is not zero, which indicates that there is a significant linear relationship, which indicates that there is a significant linear relationship between age and blood pressure. Okay, well, all right, I think that's all for solving this question using the traditional method. Well, for p-value method, I'm just going to leave it to you guys to do it on your own, but I will just state here what's the p-value for this problem here. You will see that in this case, the p-value that you will get is between 0.01 and 0.02. And because of that, you are going to compare p-value with alpha, and you can see clearly that p-value here is less than alpha, and it will lead to the same conclusion of rejecting H null. Okay, and you will come to the same conclusion, right? So for this one here, I will leave it to you guys to do it on your own, and I'm sure you can do this. If there is any question, just drop it on the comments below. All right, thank you very much for watching.